Today we're going to cover chapter 7.6. In this chapter we're going to be solving equations again, but this type of equation is called an exponential equation. This type of equation is different from yesterday's. Yesterday's equation, the variable was in the base. In an exponential equation, the variable will appear in the exponent. And if you quickly look through all of these examples, all 6 of these examples below, which we'll cover today, you can see that all of these exponents are where the x is, and all of these bases are numbers, like this base is a 4. This base is a 2 and a 16, so all the bases you see are numbers, but the exponent has the variable in it. So these are solved much differently than how we solved the other type of equations from yesterday. There's a 4-step method. The first step is to express both sides of the equation as a power of the same base. If we look through these quickly, you can see this base is 4 and this base is 4. Those are the same bases, so we don't have to do step 1 in question number 1. But when we move to all of the other questions, these bases are different. This is a 2, this is a 16, here's a 4 and an 8, a 9 and a 27. So we'll have to do step 1 in most of the problems that we do. After we get done changing, well, let's read through this note. If the bases are unequal, like they usually are, you're going to take the larger base and bring it down to a power of a smaller base. So don't get confused on this step. A lot of people like to take the smaller bases and try to raise them up to a bigger power, but don't do that. Make sure you take the larger base, like in this example, the larger base is a 16. We're going to be bringing that larger base down to some power of a smaller base. Sometimes only one of the bases needs to be changed, but in other times both bases need to be changed, and we have an example of each type of these below, so we'll see what that means. Step 2, the power rule says that you're going to multiply exponents, because oftentimes we'll have a power of a power, which means multiply the exponents. That was one of the rules we learned on the first day of this chapter. And then sometimes we're going to have a distribution that we're going to have to do, so don't forget to distribute a variable through the parentheses, and we'll get some examples of that. Step 3, if you end up, and you always will after step 2, that you'll have some power to the A, same power to the B, when the bases are the same, and these two expressions are equal to each other, then A is equal to B. And how I want you to handle step 3 is, once you get those bases to be equal to each other after step 2, or after step 1, then I want you to take these two exponents, circle them like this, and put an equal sign in between them, because you're going to make A equal B. And then you're going to have to solve that equation where the exponents are equal to each other. And then you'll be at the end of the problem. So for example, in number 1, step 1 says to express them as powers of the same base. Well, these bases are the same. They're both 4s, so we don't have to do step 1. We move right to step 2. The power rule of exponents. Well, we don't even have to do that because we don't have a power of a power in this example. So we're really going to just move to step 3, which says if the bases are the same, then you're going to make these exponents equal to each other. So circle the exponents, put an equal sign in between them, and you're going to solve the equation x squared plus 4x is equal to -3. This is a quadratic equation. We'll have 2 answers to this. So if you add 3 to both sides, you're going to get x squared plus 4x plus 3 equals 0, because you always set a quadratic equation equal to 0 before you solve it. This is factorable. X plus 3, x plus 1. So this x value is equal to -3, and this x value is equal to -1. And now I'm going to quickly check my answers. So I'm going to take my calculator out to make things go quickly, and I'm going to store -3 into x. So my calculator thinks x is -3. And let me take 4 to the power of x squared plus 4x, just like the given example, and see what that's equal to. And now let me take 4 to the power of negative 3, which is the right-hand side of the equal sign. And they're both equal to each other, so that's my check for x equals negative 3. Now I have to check x equals negative 1. So I'm going to store negative 1 into x. Now my calculator thinks x is negative 1, and then I'll just do 4 to the x squared plus 4x. And then I'll do 4 to the negative 3. So they're both equal to each other. So we have checked both of our answers and they're both good. Number 2, when the bases are different, we're going to take the larger base, which is 16, and bring it down to the smallest base possible. 16 is actually 2 to the 4th power. So we have 2 to the x plus 1 is equal to 16, which is really 2 to the 4th. And I brought this down to 2 because I want both of these bases to be the same. 16 can be expressed as a power of 2. So once the bases are the same, I don't care about them anymore. I'm just going to set x plus 1 equal to 4. And when I subtract 1 from each side, I get x equals 3. And so I only have one answer to this problem. Most of these all the rest of these problems are only going to have one answer. So now I'm going to check my answer. If x equals 3, does 2, I'll just put a little check over to the side. So I'm going to check x equals 3. So does 2 to the 3 plus 1, which is 2 to the 4th, does that equal 16? Well, yes, 2 to the 4th is 16 equals 16, so that checks out. Number 3, I have a 4 and an 8. I have two different bases, so I'm going to bring them both down because 8 cannot be expressed as a power of 4. But 4 can be brought down to 2 squared. 8 can be brought down to 2 cubed. So both of those bases get brought down to smaller bases, and what I'm going to do is change 4 into 2 squared, but that gets raised to the 3x power. 8 I changed into 2 cubed, and that gets raised to the x plus 1 power. And now I'm going to just multiply those exponents out. 2 times 3x is 6x. So we have 2 to the 6x equals 2 to the 3 times x plus 1 is 2 to the 3x plus 3. Distribute that 3 through the x plus 1. The bases are the same. We don't care about them anymore, so all we're going to do is solve this equation. 6x equals 3x plus 3. Subtract 3x from each side, and you get 3x is equal to 3. Divide both sides by 3 and you get x equals 1. So let's check that. Let's tell our calculator that 1 gets stored into x. And now let's do 4 to the power of 3x and see if that's the same thing as 8 to the power of x plus 1. And they're both equal to 64, so that one checks. Number 4, 27 is not a power of 9. So we're going to bring both sides down to a power of 3. 9 is 3 squared. 27 is 3 cubed. Now they're both powers of 3. So 3 squared gets brought up to the power of x plus 1. 3 cubed, which is 27, gets brought up to the power of x. The next step is to do the multiplication. 2 times x plus 1 is 2x plus 2. 3 to the 3x. Now the bases are the same, and when the bases are the same, I don't care about the bases. I'm just going to set the exponents equal to each other, which says 2x plus 2 is equal to 3x. And when I solve that for x, I'm going to subtract 2x from each side and get 2 is equal to x. And we're going to check our answer, so I'm going to store 2 into x in my calculator and see if 9 to the power of x plus 1 is equal to 27 to the power of x. And they're both equal to 729, so that one checks. Number 5, we have a base of 1/2, and we have a base of 8. Well, I know 8 can be written as 2 cubed, and I'm going to write it that way, 2 cubed to the 2 minus x. Now 1/2 also can be written as a power of 2. 1/2 is 2 to the negative 1 power, because remember, a negative exponent gives you a fraction. So whenever you see exponents like in number 5 and or fractions like in number 5 and 6, you're going to rewrite those as negative exponents. So this exponent is an x. I'm just going to drop that one down. So now they're both powers of 2. 1/2 is 2 to the negative 1, and 8 is 2 to the 3rd. Multiplying the exponents, negative 1 times x is negative x, and 3 times 2 minus x, 3 times 2 is 6, 3 times negative x is minus 3x. So now that the bases are the same, I don't care about them. I'm just going to circle the exponents and make negative x equal to 6 minus 3x. In just a couple more steps, I'm going to add 3x to both sides and get 2x equals 6, which means x equals 3. So x equals 3, I'll be right down. And I'm going to do 1/2, I'm going to hit my fraction button, is 1/2 to the 3rd power equal to 8 to the power of 2 minus 3, which is both giving me 1/8. So this one is checking out. I just really have one more to do. 4 can be written as 1/4 is the same thing as 4 to the negative 1, or in other words, 2 to the negative 2. These get tricky, to the x. And 8 is written as 2 cubed to the 1 minus x. Negative 2 times x is negative 2x. And 3 times 1 is 3. 3 times x is negative 3x. And now that they're both powers of 2, I just say negative 2x is equal to 3 minus 3x. Solve that for x. I'm going to add 3x to both sides and get x is equal to 3. And if you put that in your calculator, you can see 1/4 to the 3rd power is the same thing as x to the 1 minus 3, or negative 2 power. So that one's going to check also. And that's it for today.